Hello everyone, in this video I'm going to be explaining 3 tips for optimizing Docker images. Now, the fact that these are just tips you need to bear at the back of your mind. You just need to know them, and they're not rigid instructions that you have to follow through, and does not mean you have to start implementing premature optimizations and or when you just start writing your images and all, or if you're still new into like working with Docker. But they are cool things to be at the back of your mind. You know why people make certain decisions when you read through Docker files, and you get to know why some of these things happen and all of those, right? Now, so first of all, I created a very basic Node.js application, and the package.json file, I have dependencies which Express is used, but you notice all of this, I'm not using TypeScript or the types and all, right? But I just added these dev dependencies because one of the point has to do with you ensuring you're not using dev dependencies in production environment because they are not really necessary for production and all. That's why we have this. I'm just mocking what the real environment is going to look like. And I have this Docker ignore file to ensure we're not building the node models folder. And then I created this basic node Docker file, and I added comments so you know what each line is doing. Now we're going to get to understanding why we have this and this, because layering and caching is very key in Docker, in the way Docker builds images. But the first tip we're going to start with is you ensuring you choose the right base image. Now the base image is the foundation for your container. That is what you find most times at the top of your Dockerfile, and it's the first line in your Dockerfile, and it sets the tone for how big, fast, and say secure your final image will be. So you notice many developers really don't go for this kind of images. Like you see them, they attach something like slim or alpine and all, like, right now, but you may not really know why they do this, and it's because it impacts the overall size of the of your image at the end of the day. And so let me switch to my terminal. When I go Docker images, you notice there is no image right now. Now I'm going to build the image. I'm going to build an image now. Yeah, so I'm going to give it the name of image size. Now for each point, I'm going to be adjusting this, and let's just call this vanilla. For others, we're going to call it, so the tag, we're going to say slim and then alpine. But for now, let's run this. Now when we run this, it's going to build this. Now it looks fast because a lot of things are cached, because I've run this, I've used the image many times, and a lot of things are cached. You can actually see them here. A lot of things are cached, and but how you get to know this, what the size is when you come here, you notice that this is over a gig, 1.19 gig. That's like 1.2 gig, and this is gonna tell when you say push to an environment. Now this is just a very basic Docker file. When you're working with large projects, you get to like see more and like have to do with more, right? And all of this tells on what your final image looks like. And also the size, say the way you layer up your Docker file, but we're going to get there. So you see what the size looks like. Now, if we inspect the history, you get to see all of what contributes to this size. Now, say I go Docker history and I specify the Docker image name and tag, we get to like see now. If you look here now, although all of this is coming from 2 years ago, because that's like when I have like made use of the Node.js then vanilla node Docker base image, right? And you begin to see what contributes is 560, and all of this adds up to the 1.19 gig. Now there are other images. Now if you go to Docker Hub for Node.js, you begin to see other kind of images. All of this impacts on security and all. But one most popular image people use is, say you want more security, use like the slim version. You just need to attach this and say slim. And then we can come back here to, let me clear first, and then I'm going to build, and let's tag this slim. Let's tag this slim. Now when I build this, it's still gonna be fast. But okay, installing dependencies. Okay, so now when I run Docker images, you get to see the slim version, the size is 319 megabytes, and then the vanilla version is over a gig, which is like 6 times bigger than the slim version. Now I'm also going to show you the Alpine Alpine, right? And then I'm also gonna build for that. So just gonna change this to Alpine, and then it builds, and hopefully this is faster. Yeah, and then Docker images. Now you're able to compare. So see different images having different sizes. And now you begin to see how this impacts. So just the first line already impacts on the size of your Docker image. And this is something you should treat it as like making a very important decision. You should pick the lightest one that works with your application. And yeah, you can like read up the you can check out Docker Hub to see vulnerabilities. Here you also see what the compressed size looks like, so you can check for vulnerabilities and make your decision. But you just get, what I want you to know is that yeah, this plays a role in what the size of your image ends up being, right? The second thing I would like you to pay attention to is how the way you order your instructions play a key role in your Dockerfile. They play a key role in caching. Now, the way Docker works is Docker does not rebuild your image from scratch every time. Like you saw when I did the history, when I ran the history, you saw like it's pulling some layers from 2 years ago. Now, what Docker does is it builds in layers and it catches those layers like I was showing you here. Now it builds in layers. Now all of these, say if you look here, now all of these are like instructions in the Docker file. Now it builds all of these in layers and it catches those layers. So if you change a layer, say I change something here, now it means like all of these are going to like run again. Yeah, so the structure of your Docker file plays a key role, and many people really don't pay attention to this. They just write their Docker file anyhow. Say for example, here now we are copying the package.json file and the package lock.json file. And this is very important for better caching. Now, why this is better for caching is because we are only copying the package.json file, and then we're installing the dependencies before we now copy the rest of the application, right? Now, if you did it the other way around, say we are just copying the entire project here, so before we install the dependencies. Now, any change you make in your application, say you change the index.js file, is going to install the dependencies again. Now, to be very practical, so we're not just theoretical, I have this image, and I'm just gonna build, and let's call this image order, and let's say this is good. Now if you look at this, you notice that this is cached. We are not installing the npm packages, and because it is cached, we have like built the image before and nothing changed. Now I'm going to come here and adjust the index.js file. yeah, I adjust this file, and then say I build the image again, and then you notice that what's happened is this copied, like we copied the rest of the file. This did not install again because what we are touching is the index.js file. Well, we just touched the index.js file, so this did not change. So there is no need for us to install the dependencies. So it just gets to run all of this, right? But like I told you, it's building layer. So if this should change, that means all of this is going to like rerun. Imagine a situation where we are not copying the package.json file, we're just copying the entire project, right? And then we don't have this here. It means that any change that happens to our project, we're going to install dependencies. Say for example, I added the exclamation mark again, and then I come here to build. So sorry, this was supposed to be bad. I was supposed to tag it properly. But if you notice, it's taking a lot of time, and that is because we're installing the packages. And meanwhile, we did not add a new package to the package.json file. But if you look here, we're copying everything, and then there is a change. So this is not cached. And automatically, since there is a change here, automatically it's going to run everything after it again. And so you need to pay attention to the way you order your instructions because it affects the caching of your files. And now you can see how long it takes for your packages to install. Now this is just 8.2 seconds because we just have very few things that we're installing. But imagine a real application taking 30 seconds, and imagine having to do this repeatedly, and then some applications could even take up to 1 minute and all, right? And you really want to cut this kind of time, this amount of time. So you need to pay attention to how it is layered. You ensure that you always put the most stable command towards the beginning of your Docker file, and then things that are likely to change, you put them towards the end of your file, because all of this can have impact on the build time, not just the size or security. Now, this is the second tip. Now, for the third tip, it's all about ensuring you skip dev dependencies in production. So installing only dependencies we need in production. And that is why I added these dev dependencies. Now, the truth is that when you are building your container for local development, you want to install everything. It makes sense to install everything. Say, for example, you're building with TypeScript, you want to transpile to JavaScript. Say you have tests, you want to test, you want your tests to run, and the type. Now, all of these are very important in development, but in production, they are not important. So it does not make sense to install all of this package again in production. How can you ensure all of this? Now it's very simple, straightforward. What you just need to do is to add, like, say, a flag. Yeah, I think call that a flag. So we want to only, what this is saying is, oh, skip dev dependencies completely and install only the dependencies. Before we do this, so I'm just going to inspect one of the images. Say we say we open it in shell and say docker run it, yeah, I'll run this. So run ls, and then we'll see all the files. So we'll go to node modules, and then we'll do ls, and then we'll see all of this, right? Now these are like all that is being installed, and you notice that there's a lot of jest installed here. There's TypeScript, yeah, a lot of types installed here, including TypeScript. And all of these are dev dependencies. We don't need them in production. And this is going to help with that. It's going to ensure that only dependencies are installed. Now, when we save this, and then I'm going to exit this guy, and then we're just going to build a new image, and let's say image dependencies, and then good. I'm just going to run this. And then if you look here, say we do Docker images. We have the image depth good, right? And then we can just open it up. Okay, so cd node modules, alas, and then if you look here, you notice the amount of packages installed has reduced drastically compared to here. You see the number installed here. Number one, we can't see any jest here. We can't see the types. We can't see TypeScript. We can't see we can't see all of that here. So this tells you that we are only installing the dependencies that are needed for our application to run. We're not installing all of these dev dependencies and all that it brings, and all of this just in turn, this is going to reduce the time that this production takes to run, because we are installing fewer dependencies. We're installing fewer dependencies now. But the way you would want to do this in practice is multi-stage build. So instead of trying to slim down manually, because and so you don't have to create separate Docker files, say one for building locally and one for building in production. So we tend to have multi-stage builds. Now I'm going to create a new Docker file here. So I'm just going to say Docker file dot say depth, and then I'm just gonna copy code and bring it here. And what we have here is we have the stage one for building, and what this is doing is still using, I'm going to just change this to 22, and similar to what we had before, we're creating the working directory, but this time around we are copying over the entire project. And what we're doing here, we are installing everything and running a build so that we can have the dist folder. And then what we are doing here is that for production, so in production, what we're doing is, we're going to put these guys together. In production, what we're doing is in the folder, we're only copying over from here, that's from the builder stage. We're copying over the files that are in the dist folder, and then we're copying over the package.json folder. We're installing all the dependencies and all. So what's happening here is in stage one, we're installing everything and we're building our application. Now in stage two, we're starting afresh. We're pulling only the build code and the production dependencies. Now this lets you use any tool you want during build, like your TypeScript, your ESLint, Webpacks and all, without dragging all of that into the final image. Yeah, and I won't believe that the three tips we've mentioned. So the first one is ensuring you're using the right base image. The second one, you pay attention to layering, as that affects caching. And then the third one, ensure you're only installing the actual dependencies in production. Now, optimizing Docker images should not be about perfection. It's just you like trying to start lightweight, just being intentional about the way you order the instructions in your Docker file. So basically, you should just treat your Docker file like code, and because all of this affects production, the amount of storage you get to use in production, and that's all. So that's all for this video. I'll catch you in the next one. Bye.